Hi folks, today we are adding another VFD driver to our list. This is the ML9286 from the brand LAPIS. It is implemented in the Yamaha panel model TSR score 5810. It is a positive voltage driver. According to the manufacturer, it can reach up to 80 volts for the grid segments voltage. In the panel we cannot reach this value because the capacitor C4037 used in the voltage called in the schematic as a VDISP have a value of the 220 microfarads and 50 volts DC. So, for safety, we should not exceed the plus 39 volts DC for the VDISP. Also, it is necessary to check the voltage supported by the transistor which do the switching of this voltage. The panel itself has a system to meet the driver requirements regarding the initialization sequence. It requires the plus 5 volts DC first and only 10 the VDISP voltage. Also indicated in the schematic as a plus VP underscore FL. When shutting down, the process is reversed. First, VDISP is removed and only then the plus 5 volts DC of the logic. It is easy sequence to implement using logic, as they did when using the pin 42 of the processor for this purpose. However, doing this with the hardware alone requires a bit more of the work. I will give one suggestion on how to do this later in the video. Of course, we could opt for one on-off switch for this microcontroller controlled power supplies. The code used for the VFD animation is very simple. I should point out that the position of the bytes to draw the invader in the 5x7 matrix intended for use created characters is easier to visualize horizontally than the vertical. The example I used to activate the underline is controlled by the ADRAM command, bit C0 and C1. The positions of the grids and segments are very well documented in the VFD description provided by the Yamaha in the service manual, making it easy to relate then to the code used in the animation. This is the circuit I have done to control the presence of the voltage to the segments and grids. And you can see here in each branch of the power I apply a diode. This means the voltage will drop here 0.7 volts, here also. And to avoid this difference, I apply to the input 5.6 volts DC, okay? It's not necessary you do it with these values exactly, but it's necessary you have present if you apply here 5 volts to the input, you only have here 4.3 volts, okay? The circuit works okay, but it's necessary to take it account. And you can see here the both converters DC-DC from 5 volts DC to 12 volts DC. And here is the 5 volts DC to the plus 24 volts DC. It's necessary to take account the letter S at the end. This means the converter is isolated from the input block to the output block. This is very important, okay? Because you can see here I use the both converters to create a series of the power source to the output. The next note is After pass this diode here, the plus 5 volts go to this capacitor through the resistor of the 18 kilo ohms and polarize the capacitor slowly, okay? You can reach the value. Will take time to load the capacitor if you apply the multiplication of the 18 by the 100 microfarads. This will give you the time in seconds will take to load the capacitor onto the capacity of the first tau. And the first tau is the timer which result of the resistor by C. Okay, I will let the forms at the end of the video. After you load or after you reach the voltage of the first tau, the polarization of the transistor which control the switch of the voltage to the grids and segments will be on, okay? It takes a little of time to load and after active the switch. This means after you apply here the plus 5.6 volts, only after some time the switch will be activated to switch on the voltage on the grids and segments. To process to release the power is the same. When you disconnect the power, you have this capacitor here with a total load, okay? Because it's loaded by this diode here, and you have here present the plus 5 volts DC. Because the wire to the plus 5 volts logic coming to this point here, this means when you release the plus 5 volts DC, you will stay with the charge of this capacitor to load your driver, and will keep the plus 5 volts DC present, but in this meantime the value present here will be dropped because you have the diode to drive the current to the filament in this point here. This load here disappears fastly, and this means the voltage of the grids will be not anymore present and you still with the plus 5 volts DC. I marked in the schema the points where I connect the probes of the scope, okay? Channel 1 is direct to the input. Channel 2 is connected to the plus 5 volts DC of the logic. Channel 3 is connected to the point responsible to activate the transistor base Q4008 and active the next transistor. And the channel 4 is connected direct to the pins of the driver marked as a VDISP, or is the same to connect to the collector of the Q4007. Because the driver is a positive driver, we only need the two levels of the voltage. In this case, we have 36 volts to the grids and segments, and we have the 5 volts DC to the logic and to the filament. This is the connections necessary to bring the panel to life again.